For years, we viewed artificial intelligence as a digital utility. Between 2023 and 2025, it existed strictly behind glass, generating text and images only after a human typed out a specific command. But that model hit a physical limit. Cloud computing costs skyrocketed, data centers reached the maximum capacity of local power grids, and the primary bottleneck became the time it took for a human to read a screen and react. By June 2026, those constraints forced a breakout. The technology transitioned from software in a browser to autonomous physical infrastructure, operating directly within our power grids and hardware. The industry has moved past the era of teaching software how to write emails. We are now watching digital systems manage the physics of our energy grids, the safety of our cars, and the chemistry of ourselves. The scale of this new economy is evident in the financing. The Chinese firm DeepSeek is closing a single funding round worth $7.4 billion, pushing its valuation toward the $60 billion mark. The most significant investor here is CATL, the world's largest manufacturer of electric vehicle batteries. Their $740 million stake signals that the future of AI depends as much on chemistry as it does on code. This chart shows the thermodynamic reality of the industry. Operating at this scale requires an integrated system of 4 physical pillars: the computing core, the algorithm, a massive power supply, and local energy storage to ensure the system never goes dark. As the data centers expand, the hardware in our hands is shedding the traditional operating system. Microsoft's Project Solara platform represents an engineering shift away from the standard app-based model. This is an agent-first hardware paradigm. Instead of smartphones, users are adopting ambient devices like smart ID badges with integrated cameras and microphones, or desktop displays designed to remain active 24 hours a day. These devices run on a custom Android kernel built to host localized AI agents. The interface functions as a portal into a background intelligence that can log hospital patients or draft emails without waiting for a human to click a button. Computing has moved away from the model of human-initiated actions. It now functions as a layer of environmental intelligence that remains active regardless of whether we are looking at it. That intelligence is now simulating raw physical matter. The European firm Mistral is ingesting over a petabyte of historical collision data for BMW, allowing engineers to calculate metal fatigue and vehicle deformation with an accuracy that makes physical crash tests unnecessary. The ability to model physical stresses in steel leads directly to the manipulation of human biology, specifically in the high-stakes effort to treat pancreatic cancer. For decades, the RAS gene mutation was considered undruggable. The resulting mutated protein has a smooth surface without any molecular pockets, meaning there was no place for a traditional drug to attach. This diagram illustrates a breakthrough in computational chemistry. Revolution Medicines used algorithms to design a molecular glue. The compound first binds with a common protein, creating a structure that locks the mutated RAS protein in place, blocking cancer growth. The results? This AI-designed drug doubled median overall survival time from 6.7 to 13.2 months, reducing death risk by 60%. AI has moved past predicting words in a sentence. It is now designing the physical building blocks that extend human life. But the same autonomy that drives medical breakthroughs also enables destructive capabilities. Advanced models like Claude Mythos have demonstrated the ability to discover zero-day vulnerabilities in major operating systems without human help. This has created a crisis for the open-source community. Automated scripts are finding and reporting thousands of flaws at zero cost, creating a cognitive DDoS that has overwhelmed the human volunteers who maintain the Linux kernel. The humans can no longer keep up with the volume of code the machines are breaking. In response, a global alliance formed Project Glasswing. This coalition is deploying a defensive shield of AI agents, specifically designed to protect physical infrastructure, including power grids and water systems, from autonomous digital attacks. In the year 2026, protecting a physical city now requires a literal AI shield to combat autonomous AI weapons. Because AI now manages physical safety and national power, the era of a single global intelligence living in an American cloud has ended. The rise of sovereign AI has become a multi-billion-dollar industry. This is why the firm Cohere recently acquired the German startup Aleph Alpha for $20 billion, creating a localized alternative to Silicon Valley. Governments are now legislating data governance as if it were physical territory. In Europe, many models and their data are legally required to remain within national borders, ensuring that the local infrastructure stays under local control. For the everyday person, this shift is silent but constant. It is a security system in a train station identifying an emergency before guards see it, or a translation engine making language barriers invisible during a business meeting. The technology has integrated into the background of the physical spaces we navigate daily. We are leaving the era where computing was a tool we picked up and put down. We are entering an era where it functions as a persistent, automated layer of our world. Surviving the next decade requires looking up from the screen to understand the automated environment already functioning around us.